Assalamualaikum and very good day. My name is Hafizi and you are watching my channel for DASYLAB. So today I'm gonna demonstrate how to use set up the sampling rate and block size for any applications by using DASYLAB software. So first we look at this our software. There is a few windows. We have first we look at here is a modules window, which is we have all these modules that we can use or we will use for developing our programming. This is actually a module based programming. If you familiar with C++ and Visual Basic, all that thing is programming, but with language written programming. You have to write down lines by lines programming. But for this one is you only use a module. You combine all the module, and then you can create your own system. There is another software that same with this one, which is a LabVIEW, which that one is another level. I find out that this lab is easier to use, especially for the engineering student. Basically for our student in University Malaysia Pahang, because we have purchased this lab software for our applications. Okay, now if you look at this. Under this window modules, there's a lot of modules here, and then beside it we have a working area, which is a worksheet area, whereby we combine all the modules at this area to create our own measurement system. Alright, so without further ado, I will show you where we need to set the sampling, because if we learn about the measurement, the fundamental of measurement, especially on you want to convert the analog signal to digital signal, you have to make sure that we choose a correct sampling rate, so that we can either first we can avoid the aliasing, and the other one is we can properly represent the analog signal in terms of digital in digital form. We can represent it correctly without huge error, so that our computer can analyze the signal and provide to us accurate information. Okay, so now if you look at all this tab here, the file, edit, modules, measurement. Either you can use this tab to find where to set up the sampling rate. You can also use buttons. This is a buttons here. First, I'm going to show you how to use a tab. So under the measurement tab, there is a time basis or setting. So that one you can change the sampling rate for our software. It depends on what kind of device that connected to the computer. For this one, look at here. There is a driver. Driver is automatically detect here. It is actually from the sound card. So it's actually a sound card. See, it's written by sound card. So every computer usually have a sound card, and then this one, this sound card is connected to my computer. So it's appear here. And then by default it's showing the 11 kilohertz of the frequency, the sampling rate, which is it have per 1 second. It have about 11,025 sample per 1 second. 11,025 sample per 1 second. And then in one window there is 4,096 sample in one window. Alright, so what does it mean? I will gonna show after this what this information mean. First you have a look. For block size, you can choose either automatic. When you choose a sampling rate, whatever value you choose, you can either tick the box for automatic, or you can manually select the block size. After this, we're gonna see how the different block size will affect the display of the signal. Okay, so this is the first method by selecting the measurement, time basis, and all setting. There is another method. Just go to the AD, which means analog to digital setting. Analog to digital setting. If you click this one, it's automatically open up this box, and then you have, if you look here, there is a sampling rate input here. You can change, so it's basically the same. It have a default value 11,025 kilohertz, or 11,025 data sample per 1 second. And then block size, yep, if you want to choose automatically, you click automatic. If not, just you can manually select the block size. There's a lot of selection here. Either you choose from here, or you can write down manually. Alright, so I choose specify automatically, so that it can give the automatic selection what the computer suggests me to use. So I click OK. Then now I good to go. Now we see. Now I will show you by using the sound card, and also I'm going to show you by using the signal generator. So first I'm going to show you by using generator, because it's more theoretical. You can set up the input, and then you can see the effect. After that, I will show you the use of sound card or sound from the microphone. Alright, so look at here. So I want to find the modules for the generator, because I want to generate the signal. Under the control, we have a generator. Bring in. First, you just click without modulation. After this session, I will show you how to use with modulation. Okay. So without modulation, click OK. So now we have to set up the how generator will generate the signal. So we double click this one. Now you see. So I rename this one. For example, I put it as a generator number 1, because after this we're going to use maybe more than one generator. So for this one, I will set generator 1. You can put your own names, it's up to you. And then for this one, I pick up the sine. So the frequency will be the output frequency will be the 10 Hz. So I will instruct the generator to create or to generate or we generate 10 Hz signal, which is in 1 second there is 10 cycle in 1 second, with the amplitude of 4 volts. Yeah, how do I know it's volts? Because of this one, I set a unit for this one is volt. So 4 volts as the maximum amplitude. So the others, it just I leave it as by default as it is. If you look at here, there is another button for time base. For time base, we select driver, which mean, okay, this is very important, which mean if you click OK, so the sampling and the block size, you're gonna use the driver setup for the sound card. If you want to use a setup for DASYLAB, this one, you still can use it, although it's just for the software, but you must change the setting. If you're satisfied with the setting, and then you can proceed. Okay, let's say I'm going to use a DASYLAB time setting. So you have to change the setting here So I click OK, go to the measurement, time basis, offsetting, I change the Z setting. So am I satisfied with the 10 Hz? Basically, if I just now I set up a generator to generate a 10 Hz. Theoretically, I cannot sample at 10 Hz. The system will not allow. I can try. See if I can. So if I can connect YT chart here, I will explain about YT chart later. I will open this one. So if I run, it will not allow, because the sampling rate is the same as the frequency that I will show. So it's not allowed. If you learn about mechanical, about the A to D, there is a term, we call it Nyquist theorem. The sampling rate must be at least more than twice of the signal. Alright, so let's say generator, sorry, I need to stop this one first. Okay. So for generator, let's say I double click. Okay, sorry, there's a technical problem here just now. Alright, so now we have, if you look at the setting for generator 1, so I create a 10 Hz signal. Like I said, Nyquist theorem said the sampling cannot, it must be more than twice of the frequency that the maximum frequency that I use here. So this one is 10 Hz. So I must set the sampling frequency to be more than twice of this one. So times 2 is 20, so more than 20. So I go to the measurement, time basis, offsetting. So DASYLAB now is 20 Hz, so I need to change to not 20, more than 20, which means 50, yeah, 50 also, 100 also you can use. Let's say I use 100. Let's say I use 100 Hz. Okay, so it's more than twice of the original signal. Alright, so block size, it cannot be 1. I choose automatically, so it says 64. But 64 data per one window, I think is quite a low number. So I choose, there is a theoretical calculation how to select the block size, but usually I'm going to use the same amount as the sampling rate, say 1000, 100, sorry. Then okay. So so just now, no, okay, sorry. So generator, I click again. So I make sure that time basis use DASYLAB, because I set up the DASYLAB just now. Okay, okay. Now, alright. So I press OK. So it generating the signal by using a sampling rate that I set just now. I'll say sorry. Now I want to tell about the YT chart here. If you want to view time-based graph, time-based graph. So YT means Y axis Y, and T as time as the x-axis. So basically, if you do monitoring, of course it will be time basis. So basically, we're gonna use a YT chart to show the graph. So YT chart is so you can set a YT chart. I usually use auto scale. If you don't want to use auto scale, it's up to you. And then so you can the time axis, either you can use time definition for X scaling, or you can use a current date, or you use date and time. But basically I'm going to use time definition for X scaling, which is we use a normal normal time. And then you can do more details on this one. Okay, you can do more detail on this one. For example, you X scaling, you can do for example continuous time axis, which is now if you look at here 6 p.m. you're gonna use this time continuously. You can it will add up the time by using this time, or you can use a fixed window, fixed time window. For example, every 1 second, every 2 seconds, every 1 minute, it will show the frame. Alright, the rest I will let you to explore. So I leave OK. Then I press OK. I'm happy with the setting. Oh no, I will rename this one. So this one I put a graph. Graph generator gen 1. It's actually showing the short name. Okay, now it's showing the names here. So now I press this one, restore all windows. So it will open up all the windows that actually connected to this one. Basically, if you select, if you bring in the graph, any graph, it will have a window for this one, for graph, to show the graph. So if you have like for example, if you have you bring more graph, okay, let's say 2 3 graph. All this graph is connected with the same source, which is the generator. So you connect, you click this line, and you click left click to this one, and you click here. You can choose anywhere. You can click anywhere, or you can just click here from 0. Then you cannot. You only connected with one line only. So you can choose another line and then connect here. So to delete the line, simply you right click on the line. To create the line, left click. To delete the line, right click. So you right click one time to select. Okay, so this one, select this one. I select this one. Okay, either one you want to select, right click. The first click is to select, and the second right click is to delete it. Okay, delete it. Second right click. Okay, so I reconnect this one. So basically now we have 3 graph window here, which means it's actually created 3 windows for the graph. So where is the graph? You just click here, restore all windows. It will open up all the 3 windows. Alright, so 1 2 3. But basically, because of I just connect with the same source, basically it will showing the same graph. I will show the demonstration. So we have I resize this one, make it smaller. So I make it smaller. Rearrange. Then I click the button start to start the display. See, it's showing the same graph because we select from the same source. Alright, so from the graph you can simply click this one to zoom in. You can zoom in so you can see the graph in details, and then you can click this zoom out button to make sure it's back to the normal. If you remember, I choose sampling rate as I choose 100 as sampling rate. It come out something like this. So if I want to change the sampling, so first you minimize the window. You click this button to minimize all the windows. Okay. So how to change the one? Go to the measurement, time basis, or setting. Make sure that you click the DASYLAB. So 100, you change to, let's say 1000. Okay. Block size, either you remain 100 or you change to 1000. It's up to you. But for this one, I will change. I will remain with 100. Okay. Or you want to use automatic, you can click automatic. But I will not using automatic. I will use 100. Alright. So I click OK. So now you see the signal, how it looks like. I click run. So it looks smoother, but see now the signal is different because of what? Because of we select 100 block size. Okay, the ratio between block size to the sampling rate is very high. Okay, so that's why it's just showing small parts of the signal. Right. So how to fix this one? We change the block size lah. Go to measurement, time basis, all setting. Before you do all the setting, make sure you stop lah. Make sure you stop everything first. So now I use block size to be 1000, or maybe I can increase a little bit step by step. So first I increase to 500 first, and then I change to 1000 after this. We see the effect of if I choose a different block size. Alright, okay. See, now you see. Now for 500 block size, it will show something like this. Why is happening like this? You have to refer to my notes for the subject measurement and instrumentation, and notes for the subject sensors. Find out the notes, and then you see theoretically how this happened. Okay. Right. So let's say now is 500 block size is 500. So I increase further the block size, setting to 1000. Alright. Okay. And see, it become more cycle inside the. Now, something that you have to realize here, the time, the window time. So this is actually 1 second. 1 second. So if we change the block size to now 1000, we change to 500. So I run. See, look at here, 0 to 500. So it become decrease the window time. The window time become shorter. Okay. Of course, the same if you change the time basis to, let's say, 100. The smaller you pick, the smaller the window time. So I run. See, now it's become 0 to 100 millisecond, or 0.1 second. So choose wisely your block size. If we see the difference, let's say I choose time basis, so block size I choose let's say 500. Okay, then I run, so I can see here. If I zoom in, look at the signal here. Sorry, I don't want to. I think you can clearly see from here. You don't have to zoom in. See, it's very smooth. 10 Hz signal. Originally we have 10 Hz signal. I use 1000 sampling rate, so it's showing the smooth signal. So let's say if I choose measurement, time basis, or setting, sampling rate I choose say 100, and block size I remain 500. Okay. Okay. So if I run, sorry, we show you have a, sorry, it try to show more signal because of we choose block size higher than the sampling rate. That's why it's happened. So if I can zoom in, see, it have a sharp edges. It's not really accurate. not you have some kind of error here because I choose a quite low sampling rate, although it's more than twice the original sampling rate, but still it's showing quite not very nice. Okay, that's why I choose for 10 Hz signal, I choose 1000 sampling rate. It's showing the better, smoother graph. But again, like I showed just now, if you click block size more than sampling rate, it will have takes more times for them to appear, because it will try to collect more data to view the display. For example, if you use you do your exploration on this one by changing the sampling rate and block size. See what is actually going on, and then for the subject measurement, you have to write down the report to show to tell us, to let me know your opinion on what's happening if you change the sampling rate and block size. Okay, so with that, I think I'll end this session. Hopefully that this session can help you to understand how to set the sampling rate and block size for your application. For this one, I'll use signal generator. Okay, before I stop, I'm gonna show you about the sound card setting for sound card. So I click OK. So I delete this one. So generator, I delete the generator. I bring in the input driver, analog input. This is actually the sound card. I bring in and I double click to double check whether this is actually a sound card or not. So basically, see, it shows here sound card. So it's actually a sound card automatically. So for this one, there's no time basis here. So because it's automatically choose the driver time basis because it's sound card. If I can go to measurement, it will automatic. You must select this one. You have to change all this setting here to represent the sampling rate for the analog input here lah. Make sure you change the correct one. If you follow this one, no, you will not follow this one, because this one is only for the signal generator. If you choose DASYLAB for signal generator, and then it will change the setting for the signal generator. But for the driver, you must choose this one. Okay, you must change this one. Alright, so you connect this one, connect to this one. So basically I change this one to the sound card. Sound, then after OK. So I just restore all windows, only one window appear. So I click run. So this is actually the sound. Basically it capturing my sound. Alright, okay. So now if I can stop here. So that's it. It's showing the fixed window here, time. So if you want to change this one, this time for window here, you go to the like previously, you go to measurement, time basis, all setting, go to the driver, change the block size. If you want to have more windows, change this one to bigger one, let's say 1000. It will showing the bigger windows for the time. So okay, now it changed to 900. Okay, so it's up to you. You want to see shorter window or smaller window, is up to your setting for the block size. Usually for the sound, we use a maximum that can be captured by the system, because we want to capture all the signal. Because for the signal generator, you actually set a specific frequency. For the sound card, you don't know the frequency of the sound that actually generated by my microphone or my voice. So that's why we choose the highest setting for the sound card, so that it will capture all the signal. Okay, so with that, I think I will end up this session. So see you for the next video. Thank you very much.